You're standing at the edge of a slow-moving river which is 1 mile wide and wish to return to your campground on the opposite side of the river. You can swim at 2 miles per hour and walk at 3 miles per hour. You must first swim across the river to any point on the opposite bank. From there, walk to the campground, which is 1 mile from the point directly across the river from where you start your swim. What route will take the least amount of time? So if you're located here, you need to get yourself first across the river and then down to your campground. So obviously one solution is to just swim directly across the river, that would be 1 mile, and then walk 1 mile down to your campground. But as most of us know, probably cutting across the corner might save a little bit of time. So we're going to let x be this value here, which is basically how far downstream or down the river you're going to swim. And then because this is 1 mile, the distance that you would have to walk to your campground would be 1 subtract x. And then if we look at our triangle here, this would be a right-angled triangle, so this represents the hypotenuse, which would be the square root of 1 plus x squared. So that is the diagram for this question. Now, we know that we swim at 2 miles per hour and walk at 3 miles per hour, which is a speed, and we're given a bunch of distances in our diagram, but the question is asking us about time. So we need to recall that time elapsed would be the distance traveled divided by the rate that you are traveling. So the time that you're going to take overall is the time that it takes you to swim plus the time that it takes you to walk. But we don't have the time that it takes you to swim. We do, however, know how far we have to swim. That would be the square root of 1 plus x squared. And how fast we swim. That would be 2 miles per hour. And we can add that to how far we're going to walk, 1 minus x, divided by how fast we walk, 3 miles per hour. So we get that our total time elapsed is going to be the square root of 1 plus x squared divided by 2, plus 1 minus x divided by 3. And that equation will represent the time it takes us to get from where we currently are across the river by cutting off the corner and then down to our campground. So we're not exactly sure how far down we're going to have to end up swimming, but that's essentially the value that we're going to determine here. As you can see, the bottom of the slide has the answer, but we're going to go through how that answer is determined now. So we know that the time it takes has to be between 0 and 5/6 of an hour. Now I know it has to be less than 5/6 of an hour because if we go directly across the river for 1 mile, it'll take us at a rate of 2 miles per hour, plus we then walk a mile at 3 miles per hour, that's going to take us 5/6 of an hour. And then if we think about it, our x value from our diagram here, x here has to be larger than 1 because obviously, larger than 0 because we need to swim landing somewhere in here, and it can't be bigger than 1 mile because it doesn't really make sense to swim past the campground and then walk back to it. So that's how I know that my x value has to be between 0 and 1. So we're going to go through the algebra here. So here's our equation that we got earlier, and we're taking the derivative of this. So we take the derivative of the square root sign, which is an exponent to half. It becomes another 1/2, but we multiply that by 2 to get the 4. And then the derivative of 1/3, that's a constant. The derivative of negative x over 3 is negative 1/3, just to explain the parts of that. And then we're going to let t prime equal to 0. And here we have an eraser bit on my solution. And here we have simplified now 2x divided by 4 square root 1 plus x squared minus 1/3. So my next strategy is going to be making a common denominator. And then once I have a common denominator, we know that if we have a giant fraction, numerator over denominator, that's equal to 0, the numerator is what's going to provide us with some solutions. So we're setting the numerator equal to 0. And because we have a square root and an x, we cannot common factor. Please double check that you can common factor out an x here. But since we can't, we need to move the second term by subtraction or addition to the other side so that we can simplify and square both sides. And when you do square both sides, we get 4/5 equals x squared. And then we have to go and square root both sides again. Make sure that you note that x has to be greater than 0. That's why we don't have a negative square root 4/5 solution, giving us an answer of 2 over root 5 for x. So then we're going to take that solution, 2 over root 5, and make our table to verify that it is indeed a minimum value and not a maximum value. So I've determined that x has to be between 0 and 1. So I'm substituting 0.5 into my derivative equation over here. You can substitute it up here, wherever you would like. That makes sense. And I get a negative value. And then I substituted 0.9 into the same location that we substituted 0.5, and I get a positive. So that means that the function was decreasing and then increasing. So 2 over root 5 is indeed a minimum. That tells us that yes, indeed, if x is 2 over root 5 miles, then the time would be optimized, and that's approximately 0.71 hours. You might also want to present your final solution in a rationalized form by rationalizing the denominator, because we don't really like our square roots to be in the denominator. So that would be our rationalized solution.